Today's lesson, we're actually going to be starting a series of lessons on exponents. How to simplify with exponents, multiply, divide, what to do with um, radical exponents. So the next several lessons are going to be on exponents. We're going to start with negative exponents today. The first thing you need to know, and this is going to be something that we're going to build on in the next few lessons. When any base, first of all, today you're going to hear me use the word base. The base is the big number, the large number in front of an exponent. It's the factor that multiplies times itself as many times as the exponent tells it to. So when I see base, you know I'm referring to this number in front of the exponent. Anytime that we have a base with an exponent of 0, the answer is always going to be 1. 5 to the 0 power, 1. 14 to the 0 power is 1. 8 to the 0 power is 1. I should have had a negative on here. If it was negative 8 to the 0 power, it would still be 1. This is going to make more sense when we get to the lesson on dividing with exponents, but just for a quick explanation, I will show you why that is true. In order to do that, let's just look at this example here. If you have 6 to the 7th power up in the numerator, that means that you have 6 multiplied times itself 7 times. 1, 2, 3, 4, 5, 6, 7 times. In the denominator, we have 6 to the 5th power, which means you have 6 multiplied times itself 5 times. If you were to simplify this, then these 5 would cancel out these 5, and what would be left over? You would have 6 twice, 6 squared, 6 times 6 left on top. Now, if you look back over here at the exponents, you'll notice that we had a 7 and a 5. In order to result in a 2, we subtracted the exponents. So when you have the same base being divided with exponents, you're just going to subtract the exponents to get the correct answer. Now, let's back up a little bit more. Remember basic division. If you have a number divided by itself, like 7 divided by 7, that equals 1. 15 divided by 15 equals 1. Negative 3 divided by negative 3 is 1. So you would agree with me that any number divided by itself results in 1. So if we were to have, let's hold this up here, 6 to the 6th power divided by 6 to the 6th power. If you think back to the rule that we just said, we took our exponents right here and we subtracted 7 minus 5, and that equaled 2. Well, if we take the exponents here and we subtract them, we would have 6 minus 6 equals 0. So that would be 6 to the 0 power. Well, any number divided by itself equals 1. So you have 6 to the 6th power divided by itself, just like 7 divided by 7 equals 1. Anything divided by itself equals 1. So any number to the 0 power is the same thing as dividing that by itself, and it always results in 1. You need to know that as we evaluate the problems that you have on your paper today. Just remember that any base raised to the 0 power is going to be 1. Now for the lesson on negative exponents. At the top of your notes, you have a definition, which to me is a little bit confusing, but we're going to tell you what it means. Negative exponents. A non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite power. So what does that mean? We know that when we have a fraction bar or division bar, the top is called the numerator and the bottom is called the denominator. For today's purposes, I'm going to call the numerator upstairs and I'm going to call the denominator downstairs. So just for reference purposes. What this means is to get rid of a negative exponent. If it is upstairs in the numerator, you're going to move it downstairs. If it's downstairs, you're going to move it upstairs. And when you do that, it removes the negative on the exponent and makes it positive. So let's look at examples of this. If we have 3 or 5 to the negative 3 power, 5 is upstairs. It's understood that there is a denominator down here. It's an invisible 1. So we notice a negative 3 exponent, so we have to move it downstairs to the denominator. When we do that, the base stays the same, and the exponent changes from a negative to a positive 3. Now, when you have something in the denominator downstairs, you have to have a number upstairs in the numerator, so we put the 1. Now we can go one step further. Now we can ask ourselves, can we evaluate this? Well, yes, we can. We can go 5 to the third power. 5 times 5 times 5. On your calculator, that would be 5 raised to the third power if you have this little rooftop looking symbol. And you would see that it equals 125. So 5 to the negative third power is 1/125ths. Got moved downstairs. Same thing happens here with 7 to the negative fifth power. You have a base with a negative exponent. It's upstairs. You move the base downstairs. You change the exponent from a negative to a positive. You have to have something in the numerator. Now you can evaluate 7 raised to the fifth power. And I don't have that on my slide, and I don't have it memorized. On the next two examples, we have the base with the negative exponent in the denominator or downstairs. So again, as soon as we see that negative exponent, the first thing we want to do is get rid of the negative exponent. So we're going to move the base 8 to the upstairs to the numerator, and it changes from a negative exponent to a positive exponent. That leaves nothing down in the denominator. You can have it over 1, but that can also be invisible. And now you evaluate 8 to the third power. Same thing with 1 divided by 4 to the fourth power. Here you see your negative exponent. So you move the base upstairs, change the exponent to positive, and you would evaluate 4 to the fourth power. Okay, so let's see how this would look in examples. If you look up here, you see that there is one base. That base is a 2. If you see a base with a negative exponent, the first thing you have to do is get rid of the negative exponent. This is in the numerator or upstairs. So we're going to move it downstairs to the denominator. We keep the base. We change the exponent from a negative 3 to a positive 3. We have to have a 1 placeholder up in the numerator. And now, can we evaluate 1 or 2 to the third power, or 2 raised to the third power, or 2 times 2 times 2? Yes, we can. And your final answer would be 1/8. Now, this is an example where we have to remember that parentheses makes all the difference. Here you see a base of a negative 3, but that is different than a negative 3 in parentheses. First thing we want to do is get rid of the negative exponent. So we're going to move that base down here to the bottom. It does nothing to the negative in front of the base. All it does is remove or change the negative exponent to a positive exponent. Now what we have here is 1 divided by the opposite of 3 to the fourth power. That would be different if there was a set of parentheses. This one reads negative 3 to the fourth power. But since this one does not have parentheses, it actually means the opposite of 3 times 3 times 3 times 3. So 3 times 3 times 3 times 3 is 81. We want the opposite of that, so that would be negative, and there's a 1 on top. Now, if your final answer is negative 1/81st, where do you put the negative sign? You could put it in the numerator. You could put it in the denominator, or you could put it out front. It really doesn't matter the positioning of the negative sign as long as there's 1 there. Most generally, we just put it out in front like this, but it is not incorrectly written if you put it in the numerator or the denominator. Now that is different than if it was in parentheses. Let's look at the next example. The next example has the negative 2 in parentheses. First of all, we see a negative exponent, so we know we have to move the base downstairs. We keep the base just as it is. We change it from a negative 5 exponent to a positive 5 exponent. Now this says negative 2 to the fifth power. That means negative 2 multiplied times itself 5 times. Well, we know that when we have 5 negatives, that the answer is going to be negative. And 2 to the 5th power, I believe, is 32. So our answer is negative 1/32. What happens if you have more than one base? In this example, we have a base of 3 with no exponent, and we have a base of y with a negative 2 exponent. To simplify it or to evaluate it, the first thing we have to do is move the bases with negative exponents. So we only have to move this base. The 3 does not even have an exponent, so the 3 stays in the numerator. It does not get moved. The base of y has a negative 2 exponent, so we're going to move it to the denominator or downstairs. We move the base down, change it to a positive 2. Now we ask ourselves, is there anything else there that we can evaluate? Well, we don't know what y equals. Y is an unknown number, so that is as far as we can go. Your final simplified answer would simply be 3 divided by y squared. In this example, again, we have two bases. The base on top is a negative 4 with no exponent. The base on the bottom is a k with an exponent of negative 4. We are only going to move the bases with negative exponents. The negative 4 stays on top. It does not have any exponents attached. The base of k has a negative 4, so we're going to move it upstairs and change it to a positive 4. So our final answer would be negative 4k to the 4th power. In this example, we have three bases. We have a base of 7, we have a base of a, and we have a base of b. Before we do any evaluating, we first have to move things around to get rid of the negative exponents. So we start with the base of 7. It has a negative exponent attached. So we're going to move this base downstairs and it with a positive exponent. So that would become 7 squared. The base of a does not have an exponent attached. It does not get moved. It stays on top. The base of b has a negative 1 exponent attached, so it's going to move upstairs, b to the 1st power. Now, you do not have to have the 1. The 1 can be invisible, so it's just a times b. Now, can we evaluate? Is there anything else we can do to this to simplify it? Well, we can do 7 squared, 7 times 7. So our final answer would be AB, a times b, divided by 49. So remember, before you start evaluating, always move the bases with negative exponents attached. If it's upstairs, move it downstairs. If it's downstairs, move it upstairs. In this last example, we have four bases. We have a base of negative 8, we have a base of 5, we have a base of c, and we have a base of d. So let's start with the first base of negative 8. It does have a negative exponent attached, so we're going to move that downstairs. We keep the base of negative 8. We change the exponent to a positive 2. Now, that says the opposite of 8 squared. That does not say negative 8 squared. It evaluates differently. Down here at the bottom, we have a base of 9 with a negative exponent, so it's going to move upstairs. That would be 5 to the 1st power. The c stays on the bottom. No exponent is attached. Now, at the first of this lesson, we talked about what happens when you have an exponent of 0. Anything to the 0 power equals 1. Well, 1 can be invisible, so any base raised to the 0 power, even if it's a negative number, like negative 3 to the 0 power, it's always going to be 1, so that becomes invisible and goes away. So we can just kind of mark it out and let it go away and be invisible. So we move the negative 8 to the 2nd power, opposite of 8 squared took down. The 5 got moved up, the c stayed on the bottom, and the d became an invisible 1. To evaluate this, 5 to the 1st power is just 5. This says the opposite of 8 squared, which is the opposite of 8 times 8, which is a negative 64. And then we just have a c. So our final answer is negative 5 divided by 64c. So remember two things. First of all, when evaluating and simplifying, your first step is always first to get rid of the negative exponents. Whatever bases have negative exponents attached, move them upstairs or downstairs and remove the negative and make it or change it from a negative to a positive exponent. Then evaluate what you can. And remember, anything raised to the 0 power equals 1, and it can just become invisible. That is our lesson today.